Hello, Math 140 students. We're going to pick up on page 17, section 5.6. So hopefully you guys are getting pretty comfortable with the rules of exponents. So we have the product rule, the power rule, the zero exponent, the negative exponent, and the quotient rule. We've talked about these rules quite a few times throughout this chapter, and they're here again for reference. So let's go ahead and really kind of focus on our division. So here what you can see is that we have the same base, which is going to be a 2. So since we have the same base, we're going to use this quotient rule. So this quotient rule tells us is that we can distribute the n if we need to. The other thing that we kind of add on to the quotient rule is that we can kind of simplify it. So let's think about this like this. So I have 1, 2, 3, 4, 5, 6, 7 2's up on top, right? 2 to the 7 actually means that 2 is being multiplied 7 times. So down at the bottom, if I have 2 to the 4 power, then how many times are they being multiplied? It's being multiplied 4 times. So I have a 1, 2, 3, 4 2's that are being multiplied. So let's think about these being canceled. So up and down, they can cancel out. So what you're left with is 3 up on top. So your answer becomes 2 to the 3rd power. And of course, you can simplify that. So 2 to the 3rd power is going to equal to 8. So your final answer is going to be 8. So you might be wondering, like, well, what would happen if I have 2 to the 100 and 2 to like the 86? Do I really want to count out 100 2's or 86 2's and cancel them out? No. There is a better way of doing this. What you can think of is, since you have your 2 to the 7th up on top, and I have my 2 to the 4th on the bottom, you can think of this as, well, what's going to happen is you're going to do a subtraction. So you're going to have 2 to the 7th minus 4. And since you moved this to the numerator, it cancels out to be a 1. So I have 2 to the 7 minus 4. Well, 7 minus 4 is 3. So you get that 2 to the 3rd power, so you still get your final answer as 8. So now you have the visual, and now you have the computation. So when I'm looking at number 2, I'm looking at this and I'm like, okay, what I'm going to do is I'm going to move the smaller one to the bottom. So I have my 2 to the 7th. And what I'm doing is I'm going to subtract that 4 from the numerator, from that 2 to the 4 in the numerator. So because I have nothing in the numerator, it's going to default to be a 1. So just like we did before, we're going to think about this as a 1 in the numerator. And now I have my 2 in the bottom. And now I'm going to have my 7 minus 4. And remember, 7 minus 4 is 3. So now I have 1 over 2 to the 3rd power. But we already know that 2 to the 3rd power is 8. So my final answer is going to be 1 over 8. So notice that slight difference here, right? If that exponent is bigger in the numerator, then I subtract the exponent from the denominator. Versus for number 2, if the exponent in the denominator is bigger, then I subtract the exponent from the numerator. Now for number 3, you want to be careful. This is a negative exponent. So whenever we have a negative exponent, what we want to do is get that entire thing and move it to the opposite side to make it positive. So this is now 2 to the 7th, and now it's positive. So what we did is we moved to the denominator to make positive. Then, now what I can do is combine them, right? I have 2 to the 4, and since they're both positive, I'm going to add 7 now. So now I have my 4 plus 7, which is going to give me 11. And so my answer is going to be 1 over 2 to the 11th power. Now, the same thing can be done with number 4, meaning that I can deal with this part and deal with that 10 power separately. So really I have 1.08 divided by 2.4 being multiplied by my 10 over 9 and my 10 to the 4th power. And I'm going to make that 9 a little bit nicer, 10 to the 9th power. So now on my calculator, I'm going to have 1.08 being divided by 2.4, and I get this as a 0.45 times, and now what I want to do is, since that numerator in the exponent in the numerator is bigger, I'm going to subtract 4. So I'm going to have 10, and then 9 minus 4 is going to give me 5. But you have to be careful. The reason you have to be careful is because scientific notation you always want it so it's 1 so that number always has to be greater than or equal to 1, but strictly less than 10. So here, this number, if I'm looking at that 0.45, is it bigger than or equal to 1? Well, it's smaller than 1, so it's not in proper scientific notation. So I'm going to have to move this over 1 time. So in reality, I really have a 4.5 times 10. And now you have to be careful of what your exponent is going to be. So let's think about this. If I originally had 0.45 times 10 to the 5th power. Well, what does that really mean? It means I'm going to move my decimal to the right 5 times. So 1, 2, 3, 4, 5. And there's my decimal. So what I have here in my empty spaces is going to be zeros. So really I have 4, 5, and 3 zeros. So I really have here 45,000, right? And that's a comma. So 45,000. And so you want to make sure that you get to that from the 4.5 to that 45,000. So if I'm thinking, okay, well, if I have the decimal here, how many times do I have to move it to the right? Well, it would be 1, 2, 3, 4 times. So that exponent on the 10 would be 10 to the 4th power. So really, my answer is 4 times 5. Sorry, my answer is going to be 4.5 times 10 to the 4th power. Now for number 5, what you want to think about is kind of breaking these all up into its little pieces. So let's think about the 16 and the 20. So I have my 16 on the top and 20 on the bottom. Now, the next thing I'm going to worry about are my A's. I have an A to the 4 and an A to the 5. Then I'm going to worry about my B's. I have a B to the 7 and a B squared. And I also have a C in my numerator. So now dealing with these separately, well, if I'm dealing with 16 and 20, well, when I divide that, so I am simplifying my 16 and my 20. Remember, 4 can divide 16 and 20. So 16 divided by 4 is 4. 20 divided by 4 is 5. And actually, I'm going to use different colors here. So that was a 4 and a 5. Now, if I'm dealing with my A's, well, which one is bigger? So what's bigger is the denominator. So now I'm going to do the subtraction. 5 minus 4 gives me 1. Now I'm going to deal with my B's. Well, the numerator is bigger. So I know I'm going to have my B up on top. So it would be 7 minus 2, which gives me the 5. And of course, I can't forget about that C. That C is there as well. So really, I have 4b to the 5th c over 5a, which is going to be my final answer. Now, for this one, you can actually think about this as having 3 different fractions. So the first fraction is here. So I have a 32y to the 6th over 8y squared. Now, my second fraction is separated by the addition here. So I have a 24y to the 4th over 8y squared. So you see that 8y squared that I have here, that is going to be the denominator of all 3 of those fractions. So now let's think about that third fraction. So I have a negative 48y squared over 8y squared. So now I'm going to deal with each one individually. So now I have 32 divided by 8, which is going to give me a 4. And of course here, well, my numerator is bigger. So since the numerator is bigger, I'm going to have y up in the numerator. So then 6 minus 2 is going to give me 4. Now I want to deal with this 24 and this 8. So 24 divided by 8 is going to give me 3. So I have my positive 3. Now I want to deal with the exponents. Notice how the numerator is bigger. So my answer is going to live in the numerator. So since the degree is 4, I'm going to subtract it from the degree in the denominator. So 4 minus 2 is 2. And now I'm going to deal with that 48 being divided by 8. So 48 divided by 8 is going to give me a positive 6, or sorry, a negative 6. And let's think about this. If I have y squared over y squared, that means I have y times y. There's 2 of them. And down at the bottom, I have y times y. So what ends up happening is that they cancel out. So this y squared cancels out with that y squared. You can also think of it as 2 minus 2 is equal to 0, so it cancels out. So that ends up becoming my final answer. So number 7 is very similar, where I am going to be separating it into my 3 different fractions. And remember, those 3 fractions are going to have the same denominator, okay? So I'm going to go ahead and separate it out. So 28m squared n6 over 4m squared n. And now I'm going to have my second fraction here. So it's a positive 36m4n over 4m squared n. And now let's deal with that third fraction. So minus 40m squared over 4m squared n. So I'm going to go ahead and deal with that first fraction first. So I'm going to deal with the numbers. So 28 divided by 4. And I'm going to get 7. Perfect. Now let's look at these m's. I have an m squared and an m squared. Since they're exactly the same in both numerator and denominator, they cancel out. Now, remember that n on the bottom is really n to the 1. So now I know that that numerator, n to the 6, is bigger than that n on the bottom. So I know that the n is going to live in the numerator. So 6 minus 1 is going to give me 5. Now I want to deal with that 36 and that 4. So 36 divided by 4 is going to give me a positive 9. And if we think about our m's, I have an m4 and an m squared. So what's bigger is the numerator. So 4 minus the degree in the denominator, 2. So 4 minus 2 is 2. And again, I have an n and an n, which are the same exponent, so they cancel each other out. Now I want to move over to that last fraction. So now I have a negative 40 being divided by 4, which is going to give me a negative 10. And of course, I see the m squares are exactly the same numerator and denominator, so they cancel out. But I can't forget this n that I have in the denominator. So I need to keep that n in the denominator as part of my final answer. And so that is how I end up with my 7n to the 5th plus 9m squared minus 10 over n. Now what we want to do is we want to think about the division of polynomials. So we're going to go ahead and start thinking about this long division. So let's do a quick review. So if I was going to kind of review this, let's see. You would kind of tip the fraction over. So it would be 1 into 5. So here, because 1 is too small, I can put a 0. I can put lots of zeros behind it, right? So let's think about this. So now we want to think about the division of polynomials when you're dividing by a binomial. So let's go ahead and review our long division, okay? So when we do long division, you kind of tip the fraction over. So now you would have a 5 going into 1. But here, 5 is really big. It can't go into 1. So I'm going to have to borrow. So I can always put a decimal and a 0 behind it. I can put as many zeros as I want. It doesn't matter how many zeros I put behind it. It doesn't change that 1 is the same as 1.0, which is the same as 1.00, which is the same as 1.0000, right? All these zeros can continue. It still just means that it's equal to 1. So let's just go ahead and start off by putting a single 0 in there. So I have to remember that I have my decimal. So now I think about it. 5 goes into 10 2 times. So then 2 times 5 is 10, and I do my subtraction, and that's going to be my remainder. So I know that 1 over 5 is equal to a 0.2 or a 0.2. Those all mean the same thing. So let's just do it again. So for number 2, I would have the 4 out in front and the 7 inside. So I would say, okay, well, 4 goes into 7 one time. So 4 times 1 you multiply, it's 4, and then you subtract. So then now I have 7 minus 4, which is going to give me a 3. So what I end up having is a remainder. So I would say 7 divided by 4 is equal to 1, remainder 3. Okay? So it's 1 remainder 3. So 1 we would think about as the quotient, and R is representing the remainder. So the quotient is 1 and the remainder is 3. So let's take that into consideration. Now we're going to go into our polynomials. So remember, the denominator goes out in front, so x plus 2. And now the numerator is going to go inside here. So I'm going to have an x squared plus a 5x plus 7. So over here, I'm going to designate this as my scratch work. And you might be asking, well, why are you having your scratch work over to the side? Because this can get messy. And I just want to make sure that my work is neat, and then I have a designated area to not be so neat. Because there are a lot of things going on here. So I just want to make sure I keep track of everything, right? Time management is important, and also, space management is important in math, if that makes any sense. The space that you write out your problems has to be somewhat organized, even if it is scratch work. So that way you can go back and check your work. So what we want to focus on here is going to be this x and this x squared. So you say, okay, well, if I have x going into x squared, I would need one more x to be multiplied. I'm going to go ahead and make that a blue color. Okay? So what you're doing is you're multiplying x, and you're multiplying by an x, but you also have that x plus 2. So what you end up getting is an x squared plus a 2x. And remember, from the up above, you're actually subtracting. So notice that what you're doing is subtracting. So because you're subtracting, well, you can think of that as being multiplied by a -1. So you really end up getting negative x squared minus 2x when you multiply x times that x plus 2. So now, I'm going to think about this. And so I'm going to write that down below. So it's a negative x squared minus a 2x. And now I can add them together. And so the x squareds are going to cancel because they're opposite. Perfect. That's exactly what I wanted. If that did not happen, you did something wrong, go back. So now I have 5 minus 2, which is going to give me my positive 3. So now I have a 3x. And I bring down my next number, which is going to be a positive 7. So now I have 3x plus 7 as kind of my new fraction that I'm going to be going over. So I kind of start all over again. So I'm like, okay, well, if I have x here, and I want to go into my 3x, what do I need to multiply by? Well, that would be a positive 3. So I'm multiplying 3 times my x plus 2. Well, then that would give me, once I multiply that out, 3x plus 6. And don't forget, when you do this, you're really multiplying by a -1 because it's subtract everything. So I get a -3x minus 6. So now I have a -3x minus 6. So again, that 3x and that -3x, that cancels. If it did not cancel, go back, you did something wrong. So now I have 7 minus 6, which is going to give me a positive 1. So that is going to be your remainder. So you can say that your quotient is x plus 3, and your remainder is equal to a positive 1. That would be your answer. Or you can write it as your answer as x plus 3 plus 1 over the x plus 2. And you might be thinking, okay, how the heck is that possible? Well, what's happening here is that the x plus 3, that's the quotient. So that's fine. And so what you do with the remainder is always going to be 1 over the remainder. Or sorry, 1 over what you divided by. So you can see that this x plus 2 came from my original denominator, because that's what I'm dividing everything by. I'm dividing everything by that x plus 2. So what I divided by is that x plus 2. So the remainder would be 1 over what you divided by, which was that x plus 2. So let's go ahead and do another example. So I'm going to have my 3x minus 2, and I'm going to go ahead and make this a little bit bigger here. So, okay, I zoomed in. So 3x minus 2 going into my 15x squared minus 22x plus 14. And of course, I have my designated scratch work. And that's to make sure that everything is kind of organized. So again, I'm going to go ahead and start with the basics. I'm going to deal with that 3x and this 15x squared. Well, let's think about this. Well, 15 divided by 3 is 5. X squared divided by x. So that 2 minus that 1 gives me an x. So I want to multiply out 5x times this entire thing out in front. So that would be my 3x minus 2. So when I multiply this out, I am going to get, let's see, a 15x squared and a negative 10x. And don't forget that negative 1 that you're multiplying everything by. So when I do that, it should be a negative 15x squared plus a 10x. So I'm going to go ahead and write that underneath. So I have a negative 15x squared plus a 10x. And the 15x and the negative 15x squared canceled. Perfect. Otherwise, you did something wrong. Go back. And now I have negative 22 plus 10. So I end up getting a negative 12x, and I bring that down, and it's a positive 14. So just like I did before, I want to think about this 3x and this negative 12x. So let's divide. Negative 12 divided by 3 is negative 4. X divided by x cancel out. So I'm really dealing with a 4. And then it's going to get multiplied by this 3x minus 2. So I have a 12x minus 8. And what do I multiply everything by? Don't forget, negative 1. So really, I end up with and it was a negative 4, wasn't it? So I have to remember that this was a negative 4. So it's actually a negative 12x and a positive 8. So you have to be careful with your signs. I forgot it, but at least I showed all of my work, so I don't have to go back and redo everything. I caught myself, and this is why it's really important to have your scratch work really neat and organized, so that in case you see that you made a mistake, you can go back without changing too much. So I multiplied by a 4, but I should have multiplied by a negative 4. So now, without messing up my signs, I would have a positive 12x and a negative 8. So I would have a positive 12x minus 8 that I'm writing out. And they're going to be added together. So those cancel. Perfect. Otherwise you did something wrong. And 14 minus 8 will give you a 6. And that's going to be your remainder. So I'm going to go ahead, that might say my answer is going to be 5x minus 4 plus, and if I'm going to rewrite it, my remainder, remember, whatever this is, the remainder, it's going to go in the numerator. So there's my numerator. And whatever I divided by, so this is what you divided by, that 3x minus 2, that's going to go in the denominator, 3x minus 2, because that is what you divided by. Or you can just say the quotient is 5x minus 4, and the remainder that you found it to be equal to 6. So those are two different ways to express the exact same answer for this problem. So my answer, you say the quotient is 5x minus 4. The remainder is 6. Okay. Well, let's go ahead and look at number 5. This one's slightly different. The reason why this one is slightly different, well, let's think about this. I have an x to the 4 over here, and I have an x squared over here. So there are two things that you need to make sure that you always understand. You always want to make sure that you're in descending order. That means you want to go from the biggest to the smallest. That's really important. And the second thing you always want to remember is that you're ever missing an exponent, meaning there's a gap, then you want to put placeholders. So let's think about this. If I have a negative 14x squared minus 9 plus 8x to the 4. So the first thing I want to do is put it in descending order. So I'm going to rewrite this from the biggest exponent to the smallest exponent. So I have 8x to the 4 minus a 14x squared minus 9. So now I have it in descending order. So now it goes from biggest to smallest. Now the next thing that I want to do is make sure that I have placeholders for gaps. So, okay, so I started out with 8x to the 4. Perfect. Now, what comes after? So if I'm counting 1, 2, 3, 4. And I am here at 4 because that's the biggest exponent. So if that's the biggest exponent and I have it, then that's great. But then what should come before 4? 3. Do I have an exponent of 3? No. So I'm going to say plus 0x to the 3 because 3 is missing. Okay. Now I'm going to go to the next one. 2. Do I have a degree 2? Yes, I do. That is a negative 14x squared. Perfect. Okay, I got the 2 out of the way. Now, do I have a degree 1? So this would just be x. Do I have one that just says x? No, so that's another placeholder. So plus 0x. Okay, and now I have my constant, which is a negative 9. So really, to rewrite this in descending order and having placeholders, would be this here. So I'm going to go ahead and rewrite this. So I really have 8x to the 4 plus 0x to the 3 minus a 14x squared plus 0x minus 9. And my denominator, I have a 2x minus 1. So I did all of that work to make sure that I can set up my long division. So I'm like, okay, well, I did all that, so I can do the hard work. So now I'm going to have my 2x minus 1. So on the inside, I'm going to have 8x to the 4th power plus 0x to the 3rd minus a 14x squared plus 0x minus 9. So I'm going to go ahead and deal with this 2x and this 8x to the 4th to start off with. Well, 8 divided by 2 is 4. X to the 4 divided by x will be an x to the 3rd power. So remember, I'm going to have my designated scratch work. So what I'm doing is I'm multiplying 4x cubed times that 2x minus 1. And when I do that, I get a 8x to the 4 and a negative 4x cubed. And don't forget, you multiply everything by a negative 1, so you end up with a negative 8x to the 4 plus 4x cubed. So I'm going to go ahead and write that out. So negative 8x to the 4 plus 4x cubed. So that 8x to the 4 ends up canceling out. Now what I end up having is a 4x to the cubed minus 14x squared plus 0x minus 9. So again, I'm going to have to deal with this first term, that 2x. And so I'm going to deal with this 2x. And I also have to deal with this 4x to the cube now. So let's think about this. Well, I know that 4 divided by 2 is a positive 2. And x3 divided by x is an x squared. So I really have a 2x squared that's going to get multiplied by my 2x minus 1. So when I multiply that out, I'll get a 4x to the cubed minus 2x squared. Now I'm going to multiply everything by a negative 1. So I end up with a negative 4x cubed plus 2x squared. So negative 4x cubed plus 2x squared. So the first terms get canceled out. So now I have a negative 14 plus 2. And that's going to give me a negative 12. So negative 12x squared plus 0x minus 9. So now that I'm here, I still want to think about that 2x, but now that 2x is going to be dealing with this negative 12x squared. So negative 12 divided by 2. So negative 12 divided by 2 is going to give me a negative 6. If I have x squared divided by x, it's going to give me x. So again, I'm kind of running out of room, but that's okay. I'm going to get this now as a negative 6x that's being multiplied by my 2x minus 1. So I end up getting my negative 12x squared positive 6x. Now I'm going to go ahead and multiply that by a negative 1. So I end up getting a positive 12x squared minus a 6x. Now I'm going to go ahead and write that underneath. So I have my 12x squared and a minus a 6x. So when I do that, that cancels. And just kind of ignore that writing for now. I have a negative 6x minus 9. So then from here, I think, okay, well, that 2x, what am I going to do with it? Well, I want to consider now that negative 6x. So, okay, I'm going to say that negative 6 divided by 2 is going to be a negative 3. And x divided by x cancel out. So I have a negative 3 that's being multiplied by my 2x minus 1. So I end up getting 6x plus 3. And I'm multiplying everything by a negative 1. So this ends up being a negative 6x minus 3. And again, I forgot to multiply by a negative 1. So here, negative 3 times a negative 2 is a negative 6x. Negative 3 times a negative 1 is a positive 3. So now I need to multiply everything by a negative 1, and I end up getting a positive 6x minus 3. There we go. So now I have a 6x minus 3. So that cancels, and negative 9 minus 3 is my negative 12. That ends up becoming my remainder. So to give myself a little bit more room, I'm going to go ahead and erase some of my scratch work, and that's okay because I have it recorded so I know how to get back to it in case I need it. So I'm going to say that my quotient is that 4x cubed plus 2x squared minus 6x minus 3. And my remainder, what I got was a negative 12. And so that ended up becoming my final answer. So all of that to get my final answer. Okay. Well, press pause if you need it, because I'm going to give myself some more room for number 1. Okay. So now what we want to do is we want to do some more examples with simplifying our exponents. So I'm going to take this 3 here, and I'm going to distribute inside of my exponents. So really, I have my n to the negative 5, and it's being multiplied by 3. And I have my n squared, and that's being multiplied by 3. I'll make this just a little bit smaller. Okay. So I end up getting n to the negative 15 and n to the 6th power. Remember, you have to be very, very careful whenever you have a negative exponent. Whenever you have a negative exponent, it means to move it to the opposite direction. So you still have that n to the 6, but now what you did is you moved that n to the 15 on the bottom to make it positive. So by default, since there's nothing in the numerator, it defaults to be a 1. So then from here, what you want to do is you want to add the 6 and the 15 together. So 6 plus my 15 gives me 21. So 1 over n to the 21 power. So that's my exponent, 21. Now let's look at number 2. Here you can see that this negative 3 only goes to the 2. So you want to be careful about that. So up on top I have m, and I have 2 that's being multiplied by negative 3. I also have this m to the 4th power. And oh no, I have a negative exponent. It's sad, it's unhappy. So you move it to the opposite side to make it happy. So that would be an m to the 5th power. So you end up getting m, and now 2 times negative 3 is a negative 6. I have an m to the 5th power, and I have an m to the 4th power. But guess what? This m to the 6, it's negative, it's sad, it's in the wrong spot. So move it to the opposite side. So don't forget, up on top you have an m to the 5, and the denominator you already had an m to the 4, but now you added that m to the 6 on the bottom to make it positive. You moved places. So now you can think of m to the 5th in the numerator, and now you can add the denominators together. So 4 plus 6 is going to give you 10. And now what you do, now that they're both positive, well, you know that whichever denominator is bigger, so you're looking at 10 and you're looking at 5, which one is bigger? Hopefully you guys all said that the denominator is bigger. So I'm going to do a subtraction. So let's think about this. M to the 5 is smaller than m to the 10. So I'm going to do a subtraction. So I have the 10 subtract 5. And up in my numerator, since I subtracted this, because it was smaller, I'm going to have a default of 1 in my numerator. So then 10 minus 5 is 5. So my answer is 1 over m to the 5th power. Looking at number 3, it's the same process. This 2 is going to get multiplied to everything inside the parentheses, and this 5 is going to get multiplied to everything inside this parentheses. So I have 4 to the 2nd power. I have y squared times 2. And then down in my numerator, I have 2 to the 5th power. And I have y to the 4 times that 5th power. So 4 times 4, 4 squared is 16. 2 times 2 is 4. And let's see, 2 to the 5th power is 32. And 4 times 5 is 20. So let's just kind of focus on our numbers here. If I have 16 divided by 32, well, that tells me that I can divide each one by 16. So when I do that, well, then I would cancel. 16 divided by 16 is 1. 32 divided by 16 is 2. So I have a 2 in my denominator. Now I want to think about the exponents on the y. Which one is bigger? Well, my denominator is bigger. So then I have y to the 20 because it's bigger. Now I'm going to subtract the smaller one, which is 4. Now the numerator, everything canceled, so I can put a 1 there. So I really have 1 over 2 times y, and if I have 20 minus 4, that's a 16. So my answer ends up becoming 1 over 2 times y to the 16th power. Number 4 is somewhat similar here. So what you want to do first is maybe add the exponents together, because you have multiplication. So I have y, and negative 2 plus negative 3 is a negative 5. And I have a negative 4 divided by y to the negative 15. So now I'm going to go ahead and multiply negative 5 and negative 4 together. So I'm going to have y to the positive 20th being divided by y to the negative 15. So you can think of this as y to the 20th over y to the negative 15. So now that you see it this way, you might be thinking, wait a minute, this y to the 15 is negative, which means it's in the wrong spot. You want to move it up on top to simplify it. So you still have that y to the 20, but now you're moving that y to the 15 up in the numerator to make it positive. So then really, since everything canceled in the bottom, you can think of it as a 1, which means you don't even really need it. Now what you need to do is really just focus on adding. So 20 plus 15 is going to give you 35. So now you have your answer as y to the 35th power. And for number 5 here, what's going on is you have a lot of different moving parts. So you want to think about each one individually. So I'm going to go ahead and just write this big long thing so that I can write each one individually. So what I'm going to start off with, I have this negative 3. That is not an exponent. It's a negative number. That's fine. Negative 3. Now, this is an m to the 6. I'm going to leave it as m to the 6th power. That's fine. And now I have an n to the negative 1. So, okay, I have n to the negative 1. And I have my p to the negative 2. Maybe I can make that a little bit smaller. Okay. So, I'm going to continue with my m. This is an m to the negative 1. And I have my n to the negative 3. And I have my p power. Okay. So all I did was just color code it. Okay. So I have my m's in green, my n's in blue, and my p's in purple. So now I know without a doubt that that negative 3 is going to stay put. There's nothing I need to do with it. But think about this. This m to the negative 1, it's in the wrong spot. So it needs to be moved up on top. So I already had an m to the 6, but now I'm adding m to the 1 since it was negative. These n's are both negative, so they're going to switch. This is going to go, oops, let's make that blue. This is going to go on the bottom, so I have an n to the 1 on the bottom. But this is negative, so that needs to go up on top, so that's an n to the 3 in the numerator. Now this p to the negative 2, that's negative, so I need to move it down at the bottom. But remember, you already had a p to the 1, and you moved that p2 to the bottom to make it positive. So, moved terms to make exponent positive. So that's what you're trying to do. You're trying to move around all the different terms to make sure that you have a positive exponent. So if it's in the numerator and it's negative, move it to the denominator. If it's in the denominator and it's negative, move it to the numerator. So now what I need to do is just combine like terms. So I have a negative 3, and look at my m's. I'm going to add them together. So 6 plus 1 is 7. Now I'm going to look at my n's here. Which one is bigger? The numerator is bigger, so I know it's going to be in my numerator. So 3 subtract 1 is 2. And here down at the bottom, I have these p's, so add those together, it'd be p to the 3rd power. So that ends up becoming my final answer. So it may look complicated, but really it is just doing multiple steps and making sure that you know your rules of exponents. That is why we keep going back and memorizing those exponent rules to make sure that we have a clear understanding. And that is the end of this chapter. If you guys have any questions, please contact me or the Math Success Center. Thank you.